So to get started programming this macro, we're going to come down to our macro toolbar and we're going to click New Macro. And if you want, you can delete out that macro we recorded earlier. And this I'll go ahead and call support. And again, make sure the save as type is VBA and then click save. And as soon as you click save, it should open the Visual Basic editor, which I'll call the VB editor. And if you're in 2013, the VB editor will be associated with the same icon as SOLIDWORKS. However, they still are two separate windows, and it's more apparent in earlier versions where the VB editor will have its own separate icon in the taskbar. But anyway, the significance of that is that even though they are separate windows and separate processes, if you close out of SOLIDWORKS, it will automatically close out of the VB editor. So in the event that SOLIDWORKS crashes, you will lose your work if you have not saved it, so you want to be saving often. And again, if you've ever written a macro or recorded a macro in Microsoft Excel or some other Office product, you might be familiar with this environment. It's the exact same environment because this Visual Basic editor is developed by Microsoft. It's not developed by SOLIDWORKS. It's something that SOLIDWORKS Corporation integrated into SOLIDWORKS. But basically, I'll give you a quick rundown. Up here we have the menu drop downs, and the only two things I want to point out right now are in Tools. First of all, let's go to Tools References and open this up. And basically, the References has a list of all the different libraries that we could access while we're programming in Visual Basic for applications. And so since we opened this up through SOLIDWORKS, notice that certain libraries related to SOLIDWORKS are already checked and therefore loaded in. And basically, it is because these libraries are loaded in that we can use the VB editor and VBA to interact with SOLIDWORKS. If we had these unchecked, then when we typed in SOLIDWORKS API code, VBA wouldn't be able to make any sense of it. Likewise, if you went into Microsoft Excel and opened up the VB editor and opened up this references dialog, you wouldn't see anything related to SOLIDWORKS in there, but you would see, if we go down here, Microsoft Excel 14.0 Object Library. So you might be thinking, hey, could I turn on different libraries here and so I could actually control Excel from SOLIDWORKS? Or if I was in Excel, could I turn on the SOLIDWORKS references and control SOLIDWORKS from Excel? And the answer is yes. And that's one of the cool things about Visual Basic for applications, that flexibility you have in working with different applications from one single macro. So that's all I wanted to show you related to references for now. And then the other thing under Tools I wanted to show you is under Options. I would recommend that you turn off this auto syntax check, because if you have it turned on and you make a mistake while typing your code, you will oftentimes get a dialog box to pop up that tells you that something's wrong. And it gets annoying real quick because the dialog boxes aren't real helpful. They don't provide any useful information generally. And even with this off, we'll still see the mistake in red. So I recommend turning this off. Also, if you go into editor format, if you want to change anything like the background color, like you'd prefer to have a black background and maybe yellow or white text, you can do that here. You can also change the size of the font in case you need it to be bigger or smaller, depending on your preferences. So that's all I'm going to show you from the menu drop-downs. Then below that is the toolbar with shortcuts that we'll be using a lot. And of course, the one you should be using the most is Save. But then also over here is View SOLIDWORKS. If we click this, it'll actually take us back to the SOLIDWORKS application. Now, unfortunately, there isn't a button that will take us right back to the VB editor, so I just use Alt-Tab quite a bit, and that's what I'll be using throughout this series, is just Alt-Tab to switch between the two. Then the other set of buttons we'll be using a lot is right here, Run, and then over here, Reset. So this is basically how we're going to run our macros, and then that's how we'll reset our macro if we're in the middle of code while it's running and we want to end the program. Then over here on the left is the Project Explorer. If you have multiple macros open at once, they'll all be listed in here. Now, an interesting idiosyncrasy about the VB editor in SOLIDWORKS, you can't actually right-click on projects and close them. That's just a limitation. I don't know why exactly, it's just the way it is. So basically, if you have multiple projects open and you only want one of them to be open, then you actually need to exit out of the VB editor and then reopen the editor with just the macro you want. So basically just go and edit the macro you want, and then it'll appear alone. So that's kind of annoying, but it's just the way it is. Then beyond that, down here is the Properties Explorer. We're not going to use that right now, but we will use it later when we start using user forms. And then over here is the most important window. This is the code window. This is where we actually type the code that comprises our SOLIDWORKS macro. And by default, when you open up a new SOLIDWORKS macro, it's going to have these 4 lines of code. Now, to get started, I'm actually just going to teach you some basic Visual Basic programming. And in order to do that, we will not need this line or this line. So you can go ahead and delete those out. So again, before we get started actually doing anything with the SOLIDWORKS API, I just want to do a basic run through of the fundamentals of Visual Basic for Applications programming. And when we do VBA programming, or actually almost any kind of programming today, generally every single line you type is going to be doing one of 3 things. You're either going to be declaring a variable, assigning a value to a variable, or using a variable. So no matter how complex the code is that you're looking on the screen, and right now obviously there's not much, but say that we're looking at the finished product, no matter what we have up there, any one line we point to is going to be doing one of those 3 things, or maybe 2 of them at the same time. What are each of these things? What's their purpose? Well, declaring a variable is necessary because when we work with programming, everything we work with is called a variable. So for example, right now if I type int height as integer, I have just declared a variable. I've called it int height, and it's going to represent the height of, say, a box. And then if I type in int width as integer, that is a new variable and it's going to represent a width. And so in the program I'm going to write, we need to reserve some space in the memory that's going to represent the height and the width. And now different types of data takes up different amounts of memory, and that's why we declare our variables as a certain type. So in this case, I know that the height I input is only going to be an integer value, so a non-decimal value, so that's why I defined it as an integer. And likewise with the width. And so the way we declare a variable is you always type the dim keyword, and that stands for dimension, and then you type the name. And the name is up to you, it's something you choose. Now there's certain words you can't use for variable names, like for example, I couldn't use the word integer as my variable name because that's already understood as a reserved keyword by Visual Basic for Applications, and you know it's reserved because it's blue. So same thing with like sub, end, as, dim. Nevertheless, whatever else you can think of, you can use it. And in this case, I called the second part height because it is going to contain a number that will represent the height. And then I put an int in front as a prefix just so that when I'm in the code looking at the variable, I'll see that int in front and I'll know that I declared it as type integer. And you might think, well, is that really necessary? You know, why can't you just look up at the top here and see that you put it in as integer? Well, imagine that my code is 500 lines long. It would get pretty tedious to have to keep looking and figuring out what exactly the data type was. So this is a good way to kind of keep track of what the variable is, so you know what you can store in it and what you can't store in it. So again, in review, when you declare a variable, you are reserving some space in the memory. But initially that space is empty. It's been reserved, but it doesn't have anything in it. So that's when the next step comes into play, and that is assigning a value to a variable. and that's where we need to go in between the submain and in sub. So basically this is just saying start a sub procedure and call it main. Don't worry about what those brackets mean. Just know that this is going to define the block of code where the action happens. So I'm going to indent in just because it's going to make it easier to read, and I know that the code I'm about to type is within a sub procedure. I'm going to say int height equals 10. And then down below that I'll say int width equals, we'll just say 5. And with that, typing the variable name, then equals, and then the value, I have assigned a value to a variable, at least when the code is running. And of course, as you imagine, when we run the code, it's going to run from top to bottom sequentially. And you also notice that as soon as I hit enter on a line and start typing on a new line, I've defined a new statement. So the statements are going to run sequentially. And if your code gets so long that it's going way off the screen out here, there's actually a way you can wrap the statement onto 2 lines, and that's using the underscore. So if I put in an underscore and then hit enter, this is still considered one statement, even though it covers 2 lines visually. But of course, in this case, it's not really necessary, but I will use that a little bit throughout this series, the underscore, just to make things easier to read. So now, reviewing the past 2 steps, let's declare another variable, a third one, dim int area as integer. And also, I've been doing it a little fast, but as soon as you hit as, you do get this drop down to pop up, and as you start typing int, you'll see integer, and you can auto-complete that using tab. So I've been moving through that a little quickly out of habit, but just use tab if you want to auto-complete it. And then down here we'll say int area equals, and you're probably going to guess what I'm going to do here. I'm going to type int height times, using the asterisk, int width. So if you've ever used MATLAB or even Excel, something like that, I mean, you should be familiar with all the different mathematical operators. You know that whatever's inside parentheses gets taken care of first, that kind of thing. And the great thing about programming, of course, is that we can use these variables and substitute them in as numbers and get the result we want. So right here we've done a little calculation. However, nothing's going to be displayed to the user that's of interest. So let's move on to that third step I mentioned. First there was declaring variables, then we assigned values to variables. Now let's actually use the variables. Let's do something interesting with them. And typically, to accomplish this third step, we're going to use what is called a function. And later when we're using the SOLIDWORKS API, I'll be using the term API call. But for right now, I'm just going to say function. So off the top of my head, I know that the function that lets me create a message box displayed to the user is Msgbox. So just type that in, and as soon as you hit space, you're going to get this little drop down below it. This little yellow bar that tells you what arguments belong to that function. And another name for arguments is parameters. So right now, because this is bold, it's asking me for the prompt, and that's basically whatever the user is going to be prompted with. And so in this case, we actually just want to display the area. So I'm just going to type int area. And then beyond that, if you notice these other parameters, they are in brackets. That means that they are optional. It means that you don't have to include them. And so in our case, we really don't need to mess with any of those options. Like for example, we can change the button style, but we'll just keep the default. And by default, when we run this, it's just going to display a message box with an OK button. So now that we've written this, how do we run it? At this point, you'll either have your cursor inside the submain and in sub, or you'll have it outside. And it actually makes a difference when you click the run button where it is. So if I click the run button while we're inside submain, we'll get our dialog box that says 50, and we'll click OK. But if I have it outside of the sub-procedure, then there's actually some ambiguity as to which sub-procedure I want to run. And you might think, wait a second, there's only one sub-procedure. Why is it ambiguous? Well, it is possible to have multiple sub-procedures. So in that event, if you have the cursor outside of a sub-procedure and you click Run, you'll get this dialog box first, asking you which sub-procedure do you want to start running first. And in the macro we create today, we're only going to use one sub-procedure mainly, so this really isn't going to be an issue. But I just want to make you aware that you can have multiple sub-procedures in your macro, but you don't need to worry about the details of that right now. So let's step back in review. I mentioned that there's going to be 3 things we do in every macro, or at least every line will be doing one of 3 things. Either be declaring, and so we did that up here, we declared our variables, then we assigned values to variables, and then we used one or more of our variables. So all 3 steps, you can already see them in this really simple macro. So basically from here, we're just going to keep making our macros more and more complex, but ultimately boiled down, we're going to be doing one of those 3 things or all those 3 things. So I want to talk a little bit more about functions and something related to syntax. If we go up into the help, and so go to the VBA help, I can type in the name of any function or even any data type if I want to learn more about it, but let's type in the Msgbox function and double click on there, and it says it displays a message in a dialog box. It waits for the user to click a button and returns an integer indicating which button the user clicked. So basically, depending on what the user clicked, we can actually get a different return value. And that's not really interesting in the case of this message box, since we're only displaying a message box with an OK button. But let's go to that next argument, and the way I'm going to do that is just by putting in a comma. And let's go down here to yes, no. And now let's try running this macro. So there we have the 50 displayed again, but then we have yes or no. And so in this situation, we might be interested in determining which button the user clicked. And to do that, we need the message box's return value. So right now, we have not used a return value. Let's go ahead and type dim, we'll say int retval, just short for return value. Declare that up at the top. And now I want you to do this. Type int retval equals, and if I move my cursor off of that line, you'll get this box if you didn't turn off that option I mentioned earlier. So actually, let's do that now since I didn't actually turn it off. Turn off auto syntax check, click OK, and you see that it's red. So we still see that there's an error. Why is there an error? Well, here's just one of those funny things about VBA that you need to know. If you are not returning the return value of a function, then you do not need the arguments or the parameters for that function to be in parentheses. But if you are returning the return value, then you do. So basically, all we have to do here is put those in parentheses, and now it likes it. I don't know why VBA is like that. I don't know of any other language that's like that, but it's just the way it is. So keep that in mind. If you're returning a value, put the arguments in parentheses. If you're not, keep them out. Okay, so now let's display another message box, and we're not going to return the return value, and we'll just make it an OK message box, and we'll see what the user clicked. So run this and click yes, and we see that a yes corresponds to an integer of 6. And then if we run this again and click no, we see that a no corresponds to an integer value of 7. So that's basically how functions work, and we'll be using functions a lot throughout this series, so I wanted to introduce you to those now. But of course, when we program, we're not always going to be messing with integers, so let's try out some different data types. First of all, go ahead and get rid of that last line, and let's get rid of this so we're no longer returning a return value, because I'm done showing you that. And now we've declared these as integers, and we know that integers are non-decimal values. So what if we did want a decimal value in here? Well, right now, if I typed in like 10.5 and clicked run, notice it rounds it. And that's a nice feature of VBA, that it'll automatically round it and not throw an error. But what if we do want that decimal value? Well, then we need a new data type. So the data type that is most frequently used in the SOLIDWORKS API for decimal values that you should be familiar with is double. And double just means it's double the size of a single. And a single is the smallest data type that holds decimals within Visual Basic. So go ahead and just change these to double. If you want, you could use Control F and do a find and replace, but you have to be careful not to accidentally replace code you don't want. And now the prefix I typically use for double is DBL, so I'm just going to change those now. So now if we come down here and run this, notice we get 52.5. And I'm also going to take out that VB yes no, we don't care about that anymore, so we'll just do OK. And so that's how you use another data type for numbers. And another data type you'll see used a lot in the SOLIDWORKS API is long. And long is basically a bigger version of an integer. It can still only hold non-decimal values, but it can hold larger ones. So you might be wondering, well, how do you know exactly what these can hold? Well, if you go up to help, I want you to type in something like long. So long will take you to the long data type. And you can just go to this part of the menu that says long data type, but if you actually go to data type summary, it actually gives this nice chart that shows all the different data types available and what they can hold. So for example, a Boolean can either be true or false, and we will use those a little bit in the SOLIDWORKS API. Then integer can be about -32,000 to +32,000, and then you see that long, which means long integer, ups it quite a bit to over 2 billion. And also notice the storage size. We've moved from 2 bytes to 4 bytes. And then if we move down, you see there's single, which I mentioned, and then double, which is 8 bytes, so pretty large and lets you hold a lot of decimal values. If you wanted to hold really, really huge decimal values, you'd use decimal, but I don't think I've ever used that once in my time programming. As we move down, another data type we'll use constantly with the SOLIDWORKS API is object, and I'll talk more about that in a little bit. Then there's also string. So string is going to let us hold alphanumeric characters, so basically text, things that we don't want to simply be numbers. And then down below that is variant. And a variant can vary, so basically it can be used to hold any data type, any kind of data. And you might be asking, all right, well, if it can hold any type of data, why not just constantly use variant and keep it simple? Well, again, look at the size, 16 bytes. That's a lot bigger than the other ones. And so since we need to reserve a space in the memory that can hold anything, we have to reserve quite a bit of memory because we don't know what's coming our way. So doing that, declaring everything as variant, you could do that, but it's considered very sloppy programming. Basically, you'd be using more memory than is necessary, and it's just not really a good habit to get into. And of course, computers are very, very fast these days. What is it really going to matter in a small little macro if we're taking up 16 bytes versus 4 bytes? Well, it won't make a big difference, but it's just good programming practice to get into to declare your variables properly starting off. So let's go ahead and get out of here. And the next thing I want to show you is the string, which, as I mentioned, can hold text. So let's come back up here to the top, and I'm going to type dim str text as string. And then down here, let's say str text. Oh, actually, that reminds me. I accidentally typed in that E uppercase, but just so you know, there is no case sensitivity in Visual Basic. So even if I type it like this, once I assign the value and then move my cursor off this line, it'll actually snap to whatever you declared it as. So you can actually type everything lowercase, uppercase, whatever you want, and that's fine. Anyway, so str text equals. When you assign a value to a string, you need to put the value in parentheses. So we're going to type in some characters. We'll say the area of the rectangle is, and then put a space. And as soon as I move my cursor off this line, notice those snap down to lowercase, reflecting this. And we forgot to change this, and yet the macro still worked anyway. And the reason is because Visual Basic for applications, it's very beginner friendly. It allows for a lot of mistakes like the one we just made. And basically what happened is when it encountered that int height, even though int height was not declared, it automatically declared it for us in the background. But that meant that these guys up here were never actually being used. So we were actually using up a significant amount of memory compared to what we intended. And again, since we're dealing with mere numbers and small strings here, it doesn't really matter, but obviously when you're writing a serious macro, you want to be careful to avoid those kind of errors. So let's change these as well. And anyway, back down here, str text equals the area of the rectangle is. So now what I want to do is I want to include the string in the message box. So when I click run, it'll say the area of the rectangle is, and then it'll print the area. Well, to do that, I'm going to type str text, and then to combine the two, I'm going to use the concatenation symbol, and that is simply an ampersand. So now when I run this macro, I get a dialog box that says the area of the rectangle is, and it came up with blank because I still need to change that to DBL. So let's run that again. The area of the rectangle is 52.5, and that's exactly what we would expect. So that's how you use strings, and we'll use strings quite a bit with the SOLIDWORKS API when we need to do things like specify file paths or something like that. One other thing I want to mention is you notice how many mistakes I was making there as I'd forgotten to rename these variables, and you might be thinking, all right, well, I can see myself doing that as well, especially in a larger macro. Is there any way I can have Visual Basic tell me if I've made that mistake? And there is. If we go up to the top of our code and type in option explicit, then basically what will happen is, let's say that we still had this on int area, and we tried to run this. We would get this dialog box that says variable not defined, and it would automatically highlight the variable that was not declared. So that might be something you want to use so you don't keep making the mistakes I was just making. And notice it actually stopped running the macro at this line, but if we want to continue running it, we just go up and press the continue button, and there it runs the rest of our macro. Next up, I want to show you real briefly Boolean variables and then also how to use conditional statements. So we're not going to use Booleans today in this series, but just real quickly I want to show you, for example, if we do bln, we'll call it size as Boolean, and maybe we were going to use this to specify whether the size of the rectangle was over a certain value or not. Well, at some point we would need to assign a value to that Boolean variable, so what we would do is just say bln size equals, and when you hit the equal sign you see that you only have the option of true or false. And so that's how you assign values to Booleans and use that. But we're not going to do anything with that right now. Instead, what I want to show you is how to implement conditional logic. So let's say, for example, that we want to prevent DBL area from ever being negative, because that wouldn't really make any sense to have a negative area. So what we could do is, before we calculate DBL area, is type this. Start off with if, and that's a reserved keyword, of course, if, and then we're going to type a statement that we test. So we'll start with DBL height. If DBL height is less than 0, then, so that's another word you have to type on the end, go to the next line, hit return again, and type in indif. And basically, if this statement is evaluated as true, then whatever is between these two lines is going to be run. And if it's not true, then it'll just move past this if-then block, and it'll run whatever is past it. However, what we want to do is actually also add in an else statement. That way, what will happen is, if it's true, it'll run whatever is in between here. Otherwise, it'll run whatever is in between else and indif. So depending on what you want, you may not want the else. It is optional, but I do want it. And notice that I'm doing some indenting here. Why am I doing that? Basically, I'm indenting this code just so it is easier to read, because as you create more and more if statements, it's going to become more and more difficult to read if everything's bunched up against the side. It'll be very difficult to just glance at your code and get a general feel for the logic that you've implemented. So that's why we indent with what are called nested statements. So these statements are nested within an if-then-else code block. Again, this is going to run if this is false, but if it is true, then what we're going to do is we're going to display another message box that says, please enter positive values only. And if we want, at this point, we could type in some code to cause the macro to end. And you can do that actually just by typing the word end. Now, of course, we don't really need this, because if there's nothing after this end if statement, then nothing else is really going to run anyway, so it won't matter. But let's just say that you did have code beyond this if then else statement that you didn't want to be run, then you might just end the macro right there. So we'll go ahead and keep that there. And now let's go back up here and let's try making that negative. And if we run this, we get please enter positive values only. And if we remove that and run this, we get the area the rectangle is, and we have the value. Now let's take it a step further and actually also test for whether DBL width is negative. So what we'll do here is we'll say if DBL height is less than 0 and, or excuse me, let's say or DBL width is less than 0, then, so that way either one of them can be negative. If I had the and in there, then they would both have to be negative to trigger this, but we'll just put in or. So that should protect us from the user entering any negative values. But notice also I've kept saying the user entering values. Well, right now it doesn't seem like the user is interacting much with this macro. We're just me, the user. I'm just clicking run and it runs. So let's actually include a function here so that we can get a value from the user. Let's remove that 10.5 and let's put in this function called inputbox. And since a return value is being returned already, it's going to be equal to DBL height. We do need to have parentheses. So the prompt I know is a string. I made that assumption down here too with Msgbox, but I didn't explicitly state it. But if you aren't sure whether the prompt is a string or something else, you can just look in the VB help. But for prompt, let's say please enter a height. And notice that the rest of the arguments, or parameters as they're called, are in brackets, so that means we don't need them. But if we wanted, for example, I could put in a title. I could say Keith's macro or something like that. So now let's take all this and we'll copy it and we'll replace that 5, and then I'll change this to width. And now let's run this and see what happens. Please enter a height. So I'll say 10, and for width I'll say 20. The area of the rectangle is 200. So it works just as we would expect. So that concludes our basic look at Visual Basic programming, although I do have one more variable to talk about in a moment, and that's the object variable. But before I show you that, we can get rid of this code. If you want to save it and keep it, you're more than welcome to, but I'm going to go ahead and get rid of it.